All right. Back in Algebra 1, you were given similar examples to these, but then you were asked to like map out all the possibilities and write all the possibilities down. Since then, in Algebra 2 and other classes, we've kind of changed that up a little bit. Right? So the fundamental counting principle basically says if one event can occur in a certain number of ways and a second event can occur in another amount of ways, okay, all you really have to do is, and all they're going to happen in sequence, just multiply the two numbers. Okay? And you can extend this for any number of events, like maybe it's 10 or 20. It doesn't just have to be M and N. Okay? Basically, the way I taught this in Algebra 2 is the blanks. Put the blanks down, put how many options there are for each blank, and then multiply. So this one here, you're purchasing a new car using the following manufacturers, car sizes, and colors. How many different ways can you select one manufacturer, one car size, and one color? So basically, the first blank would be your manufacturer, right? And how many options do you have? Well, I have 3 potential options there. The second blank here is your car size, where you have 2 options. And the last blank is, well, you have 1, 2, 3, 4 options, correct? And so if you go ahead and you multiply those, that'll tell you how many ways you can jumble those up in a way. Okay? And it is 24. So counting principle, can save you some time, most definitely. Okay? Any questions on that one? Again, you've seen that kind of stuff before, so that's good. Permutation. Anybody remember what that is? Heard it? Yeah? I think this is under the PRB button on some of those calculators. An ordered arrangement of objects. In other words, meaning order matters or does not matter? That matters. Okay. So what that means is if I change the order of the objects, that counts as another possible permutation. Even though they might be the same objects put there, if I rearrange them, it counts differently. Okay? And they're saying if you just have n objects and you want to jumble them all up, all you have to do is take n factorial. Okay? So if I had four books and I wanted to know how many different ways I could jumble them up, or maybe I had a 4-letter word and I wanted to jumble it up in like a word scramble, there's lots of ways I could do that. And you would just have to take 4 factorial to do that. Okay? So example 2 says the starting lineup for a baseball team consists of 9 players. I think we all know that, right? 9 people playing. How many different batting orders are possible? It's a bigger number than you think. Just take 9 factorial, which really means 9 times 8 times 7 times 6 times 5 times 4, 3 times 2 times 1. Of course, you could do that, or you could find the factorial button on your calculators. And for most of you, it's going to be under the PRB button, those of you that have the TI 32Xs or whatever they are. And for the rest of you, I think it's under Math, I believe, and then you go over to PRB or probability, right? And then it's down there, right? But you got to type your number first, and when you do that. But really, isn't this kind of like the blanks? Here's the first spot in the lineup. How many people can go there? 9. In the second spot, well, you already put somebody in, right? So 8 people. So really, isn't it pretty much just the blank idea? It is, but it's a much more quicker way of doing it for bigger numbers. And you, again, are probably a little surprised by this number. So, and that's just with 9 people. Most of these teams have people on the bench, too. So imagine how many orders there are now. Obviously, normally, certain people will bat first, and certain will bat third and fourth, and certain people bat last, okay? But there's a reason to that, but that's not what we're looking at here. We're just looking at how many ways could they jumble it up if they wanted to. And 362,880 with just those 8, or just those 9 people. Okay? Any questions on that? permutations of n objects taken r at a time. Well, how's that different from this one back here? Okay, but there was an n here, so how's this different on the next page? Well, yeah, you only take some of them, right? Here I'm taking, there were 9 people, I wanted to jumble them all up. So all you have to do is that factorial, that's pretty simple. But here we're saying, oh, maybe there's 9 of them, but I only want to jumble up some of them. Maybe those last 3, it doesn't matter, I just want to find out how many ways I can jumble it up. Well, the number of permutations of n objects taken r at a time is given by that formula. And we're actually going to do one by hand here, and then I will, because most of you know where that is, but I think it is helpful to actually know these formulas. So that top n factorial is just saying, well, that's how many ways you can just jumble them up if you had them all. And then you're going to divide by, I guess you could say, the ones you don't want. In a way, you could think of it that way if you want. So there's 43 race cars started the 98 Daytona 500. How many ways can the cars finish first, second, and third? So basically, how many of them do I want to take? I want to take 3 of them. Okay. So I know there are 43 of them, right? A lot of people say pick, right, for P, but it is permutation. Basically, I want to know how many ways can I find those 3. Now, in here, does order matter? Yes, because I want first, second, and third. So order does matter. That's why it's a permutation. Okay? And so the nice thing is it does it for you. Well, let's go ahead and fill in this formula then. Well, here is 43 factorial on top. Then you have to take 43 minus whatever r is on the bottom. So that is 3. So the number on the bottom would be 40, right? Now, if we know what that means, we know this means 43 times 42 times 41 times 40, and it keeps on going, right? You're going to divide by 40 times 39 times, you get the idea? So a lot of it cancels, right? And so 40 on down basically cancels, and I'm left with a 1 on the bottom, right? So really it's just 43 times 42 times 41. And if you think about it, that kind of could be thought of as those blanks again, first, second, third. How many people can finish first? 43. How many can finish second? Well, only 42 then, right? Because you're not going to finish first and second. Right? And then 41. So you can, again, kind of use that blanks as a fallback if you start getting a little confused. But as the problems get more complicated, the blanks don't work quite as well anymore. Okay. And how many is that, by the way? 46, you said? Once again, probably a higher number than you anticipated. Let's face it, with the way they do Daytona now with the restrictor plates and everything, I mean, like 12 of them actually finish the race. Only allows them to speed up so fast, the restrictor plates, and so they're all in one big line. So one person crashes, like 12 people crash. Yeah, so, yeah, you can't. You go faster as a group than you do alone, because of aerodynamics and drag and everything. So they can go much faster if they stay in a group. If you're out there by yourself, they just keep going around you. Distinguishable permutation. I think we used to call this repeats. Okay. Again, can you tell the difference from one switch to another? So here's the number of arrangements that are noticeably different. I think a lot of times when we did this in Algebra 2, we used the words. All right. In other words, no parts of the permutation are identical. Or the permutation itself, you make it. Yeah, I'll clear that up, I think. Or if they are identical, you take them out. If they're identical arrangements, you remove them. And this is a much different notation than what you saw in Algebra 2, but it's the same thing. It says basically you take n factorial, how many of them are there, and you jumble them up. And this is just your repeats down here. That's all this is. I think in Algebra 2 we did like p factorial, q factorial, and all that stuff is what we did there. These are the things that are identical. For example, what was the one we did? I can't even remember, but maybe we did street or something like that, right? Like that. If I switch the T's, are you going to be able to tell? No, if I switch the E's, okay, if they were typed, obviously you can't hear because I hand wrote it. If I switch the E's, are you going to be able to tell? No, so that's why they're saying distinguishable. If I switch the E and the R, yeah, you're going to notice that. Okay, if I switch the T and the S right here, you're probably going to notice that. But if I switch the T's, not really. If I switch the E's, you're not going to notice. Okay, so here, this N here would be like the E's, right? So it'd be 2 factorial because there's 2 of them. T's would be this one here, and they just say it keeps going until you're done with all your repeats, is all that's saying. It's just a notation. N sub k, yeah. Because they're saying there are basically k different repeats. Here that k would be 2 because for street, there's like 2 separate repeats. So I don't know how many of you have gone into a subdivision of a major city, but it's very hard to tell where you are because all the houses look the same. Okay, that's because when they developed that, it was way quicker for them just to keep building the same house over and over again because they could mass produce them. So all the houses look the same, right? Well, here they're saying this subdivision, they're going to try and switch it up a little bit. They're going to have 6 one-story houses, but guess what? Those 6 houses are all going to look the same. Okay, 4 two-story houses. Yeah, there are going to be 4 of them, but all 4 of them are going to look identical. They're going to look the same. And 2 split-level houses. Okay, but those 2 again will look exactly the same. So how many different ways can they arrange those houses throughout? Maybe they got all these lots. They want to figure out where should I align it. Well, how many ways? Let's just figure out how many houses we're talking about. So we got 6, 4, and 2, right? So let's face it, the first thing we would do is say, well, there's 12 of them. Let's find out how many ways I can jumble them up, right? Let's just figure that out. 12 factorial, that would be your top. That's what this is. How many ways can I jumble them up? But down here is saying there's a lot of ways that if I just switched, let's say I switched the 2, there was a 1-story house over here and there was a 1-story house over here and I just swapped them. Would that count as a different arrangement? Would I be able to tell? No. So that's not distinguishable, is it? So then what you're going to do is you're going to say, well, if there's 6 of those, I'm going to divide by 6 factorial because I can't tell the difference between those 6. Okay? And this next one says 4 two-story houses. So do I divide by 6 factorial again? Or you divide by 4 factorial because those 4 I'm not going to be able to tell the difference. And then the last one is 2 factorial. Now you want to be careful how you use a calculator on this one. What some people do is they just, because that denominator is going to be your problem. If you're really good, you're just going to put parentheses around that after you divide. Or what some people do that are struggling with calculators, they'll just find out that denominator first and then do 12 factorial divided by that number. Whatever way works, but you know, be careful, I guess is all I can say. When you try and figure out something like that. Again, you could do it by hand. You can narrow it down pretty quick by hand, but because of how factorial works. But go ahead and see what you can get. Do you understand what I mean by repeats now? I think kind of they have to be distinguishable. And what'd you come up with? Yep. Again, that's distinguishable. You can tell the difference. That's what that word means. How are we doing? This is like what a review of about 4 sections of algebra 2. Yeah, one day we can do it. Combinations of n objects taken r at a time. In combinations, the order does not matter, so there's no significance to the order. That's kind of, I think, what we did before. For example, when we did the first, second, and third place before, we would say, how many different ways can people finish in the top 3? Not caring if you finished first, second, or third. You see how order doesn't matter anymore? We just want to know if you finished in the top 3. Don't care if it was first, second, or third. Did you finish in the top 3? And then that would be how we could change that problem. And this is NCR because it's combination. And this is a very, very similar formula to permutation formula. What's the only difference? Yeah, we multiply by r factorial on the bottom. So we're dividing out more. You agree? Would you agree with that? So then is this number going to be smaller or bigger than the permutation? Why is it smaller? Because you just want to find out how many ways can they finish 1 through 3. Not if they're first, second, and third, just how many ways can they finish in the top 3. That's obviously going to be lower, okay, because you don't care. Because if I switch first and second place, does that change? Is that a different combination? No, it's the same top 3. But what if I switch it and try and do a permutation? Is that different? It is. It's first, second, and third has changed. Okay, that counts as different. So here, how many different ways can a manager, I almost said manufacturer, form a 3-person advisory committee from a group of 10? So does it say here that I want to pick the most important first and second important? No, it doesn't say. There's no value given to being picked. So I just want 3 people. And so according to this formula, this would be 10 people chosen 3 at a time. That's how some people say that. Instead of pick, they say choose. But it does mean combination. So that would be what? 10 factorial over, well, we know 3 factorial goes here, right, if we use the formula. And what goes in the parentheses here? 7 factorial. So once again, some of these by hand really aren't that bad. Right, I'm going to stop there because this 7 factorial is going to take care of all that, right? Everybody see that? That 7 factorial takes care of all of that. And this is, well, this might confuse you, but you see that that's really just 6, right? So if that's 6, I can take a 2 out of here, makes it a 3. Take 3 out of there, makes that a 3. 120. See, who needs a calculator? Just simplify. Yes. So 120. Now, with all those huge numbers we've been getting, is that surprising that that's so low? Not really. Let's just use the 7 we've got in here. I'm saying I'll take U3. Okay, and then I'll say I'll take U3. And I'll take U3, and then I'll take U3, and then see, there's not that many ways, is there? Okay, I'm not saying I'm going to pick U, U, and U, and then I'm going to pick U, U, and U, and that's different. Okay, it's still the same 3 people. Doesn't matter. Okay? So that is actually believable in that case. Okay? So do you understand the difference between a combination and a permutation? Okay, order matters or order doesn't matter. And hopefully you understand when I say that what I mean by that. That if you change the order, it counts as a different combination or a different grouping. I think that's pretty straightforward. Went all right.